Welcome to The Explainer. Today, we're going to talk about a technology that fixes one of the biggest headaches with AI chatbots, the fact they don't know anything about what happened yesterday. It's called RAG, and believe me, it's making AI way smarter, more accurate, and a whole lot more useful. So let's just get right into it, because we've all been there, right? You ask some super powerful AI a simple, timely question like, hey, who won the game last night? Or what's the deal with that big news story today? And what you get back is this polite little message saying its knowledge stopped sometime in the past. It's a super common frustration, and it really points to a basic limitation of even the most powerful large language models, or as we call them, LLMs. Now, to really appreciate why the solution is so clever, we first have to get crystal clear on what the problem is. And it's not just one thing. It's really a set of three core limitations that keep these incredibly smart models from being truly up-to-date and reliable. Okay, so first, like we said, they have that knowledge cutoff. They were trained on this massive but totally static snapshot of the internet that just ends on a certain date. Second, because they're basically just predicting the next word based on that old data, they can't tell you where they got their information. And that, well, that can lead to what we call hallucinations, which is just a nice way of saying they confidently make stuff up. And third, they've got a pretty limited context window, which means they can't read a giant report or a whole book all at once to answer your question. So what's the fix? How do we give these powerful digital brains, a library card to the world's current information? Well, that's where this surprisingly simple but brilliant technique comes in. It's called RAG. The most important word on this slide is before. See, RAG isn't about fact-checking an answer after the AI has already spit it out. No, it's about doing the research first. It goes out, finds relevant, up-to-date info from some external source, and then hands it to the LLM along with your question. It basically changes the whole game from a closed-book test to an open-book test. And this quote from Ars Technica just nails it. It's not about replacing the LLM, it's about augmenting it. Think of it like giving your super smart but kind of isolated AI a personal research assistant, one that can sprint to the library, find the exact right page in a book, and hand it over at the perfect moment. Okay, so let's move on and see how this actually builds a much smarter workflow. Because on the surface, you're still just asking a question. But under the hood, RAG completely transforms that simple little interaction into this dynamic, multi-step process. This side-by-side comparison makes it so clear. See, without RAG, it's a simple two-step. You ask, it answers from memory. But with RAG, you've got these crucial new steps sandwiched right in the middle. The system goes out and retrieves relevant facts from a knowledge base before the LLM even starts thinking about the answer. And this diagram here, it shows you the whole cycle. Let's focus on that core engine in the middle. The user's query kicks off a search. That search combs through an external database to find the right info. Then, that info is retrieved and combined with your original question to augment it. And only then is it passed to the LLM to create that final, fact-grounded response. So here's the absolute key. The final prompt, the actual instruction the LLM sees, is way richer. It's not just, hey, what is X? It's more like, okay, using the following information I just found for you, and here's the relevant text, now please answer the question, what is X? It completely grounds the model in reality. Okay, but that retrieval step, it kind of feels like magic, doesn't it? I mean, how does the system instantly know which document, out of maybe millions, is the relevant one for your very specific question? Well, this is where it gets really, really cool. The secret here is that it's not searching for keywords, not like a regular search engine. If you ask a question about advancements in AI, you don't just want articles that have that exact phrase. You want to know about machine learning breakthroughs, new kinds of neural networks. You want to search for meaning. The way it does this is by using something called embeddings. So try to picture it like this. Every single piece of text, a word, a sentence, a whole paragraph, gets converted into a long list of numbers. We call that a vector. And that vector acts like a unique coordinate for that piece of text on this giant invisible map of meaning. And here is the absolute key to the whole thing. On this map, chunks of text that have a similar meaning are plotted really close together, even if they don't use the exact same words. So when you ask your question, it also gets turned into a vector and placed on the map. The retriever's job is simple. Just find the document vectors that are closest to your question vector. So for instance, on this map of meaning, the vectors for banana and pear would be right next to each other because they're both fruits. But the vectors for apple, the fruit, and phone would actually be really far apart. Even though the word apple is in the name of a phone company, the system understands the context, the meaning, not just the word itself. All right, so we've gone from a simple question all the way through vector searches and augmented prompts. Let's pull the camera back a bit. What does all this technical stuff actually mean for you, the person just trying to get a straight answer from an AI? Well, the payoff is huge. First, accuracy goes way up because the answers are based on specific text you provide, which slashes those annoying hallucinations. The timeliness problem, solved. You can hook the AI up to a database of today's news or even your own company's internal documents. And all of this builds trust, because now the AI can often show you its work and cite the exact sources it used to come up with its answer. And that, right there, is the fundamental shift. We're moving from a world of static AI encyclopedias, full of information but totally unable to update themselves, to a world of dynamic AI researchers that can find and use new information in real time to answer pretty much anything you throw at them. So that's the big question that RAG leaves us with. By giving AI real-time access to the world's information, we're really just starting to unlock a whole new frontier of what's possible. And this is just the first technique we're covering in our series on enhancing LLMs. We're going to explore even more advanced methods that build on this idea in our next explainer. Thanks for watching.
Welcome back to The Explainer. Last time, we dug into RAG, the technique that basically gives an AI an open book test. But what if there was a way to do it that's simpler and a whole lot faster? Well, today, we're looking at the next step in that evolution, Cache-Augmented Generation, or CAG for short. Let's dive in.
So, we all know the big, nagging problem with large language models, right? Their knowledge is frozen in time. So how do we get them up-to-date, relevant information without creating a massive, clunky system that slows everything down every single time we ask a question?
For a while now, RAG has been the go-to answer. It's like that open book exam. For every single query, the AI has to run over to a digital library, find the right book, flip to the right page, and bring the answer back. It's powerful, for sure, but that constant back and forth, it's slow, and it means you have to build and maintain these complex systems like vector databases.
So here's what we're going to cover today. We'll start by comparing the old way with the new way. We'll get a solid definition of what CAG actually is, and of course, look under the hood to see how it works. Then, and this is the fun part, we'll talk about the breakthroughs that suddenly made this all possible. We'll figure out when you should pick RAG versus CAG, and wrap up by looking at what this all means for the future of AI.
Okay. Let's kick things off with a really simple analogy. Think of it like this. If RAG is like cramming for an exam by doing a frantic library search for every single question, then CAG is like giving the model the textbook weeks in advance and letting it read and absorb everything it needs to know before the test even begins.
And that right there is the fundamental shift in strategy. RAG is reactive. A question comes in and then it goes to find the data. CAG, on the other hand, is completely proactive. It loads all the relevant info directly into the model's working memory before anyone even types a single character. This one little difference has huge implications for both speed and simplicity.
All right, let's get to the main event. What exactly is Cache-Augmented Generation? It's a surprisingly elegant approach that just strips away a ton of the usual complexity, and it's quickly becoming a favorite for a lot of developers.
Okay, so the official definition is that CAG is a method where you take a specific, contained set of knowledge, think a product manual, or a specific set of company documents, and you load it all right into the model's context window up front. The key here is that it completely sidesteps that slow, real-time retrieval step that defines RAG.
Now, I know what you're thinking. That sounds almost too simple, right? Just stuff it all on the prompt. But the real magic isn't just about preloading the data. It's about how the model can process all that information efficiently. And this is where something called the key value, or KV, cache, comes into play. Let's break it down.
So the real genius is in step 2. See, the model doesn't have to reread that entire massive document for every new question you ask. It processes all that knowledge just once, and then it stores a kind of compressed summary of it. These are the key value pairs from its attention mechanism in a special cache. You can think of it as pre-computed memory. So when your query comes in, the model just looks at your new question and this ready-made cache, making the whole thing unbelievably fast.
So if this approach is so simple and fast, why haven't we been doing it for years?
Well, it's because two absolutely massive technological shifts happened almost at the same time, basically overnight, that turned this from a neat idea on a whiteboard into a practical, powerful reality. This is the plot twist that makes CAG so exciting right now.
First, and most obviously, context windows just exploded. I mean, it wasn't that long ago we were excited about a few thousand tokens. Now models are coming out with context windows of up to 2 million tokens. To put that in perspective, that's enough space to fit entire novels, a huge codebase, or a company's entire internal documentation right into the prompt. It's just a completely different scale.
The second part of the breakthrough was the cost. It's one thing to have a huge context window, but it's another to be able to afford to fill it. And just as these windows got bigger, the price per token absolutely plummeted. All of a sudden, stuffing 1 million tokens into a prompt went from being ridiculously expensive to totally feasible for a lot of real-world applications. It's this one-two punch of massive space and low cost that really unlocked CAG.
So that brings us to the big practical question. When do you use RAG, and when is CAG the smarter choice? And look, this isn't about one being better than the other across the board. It's really about picking the right tool for the specific job you're trying to do.
This table really lays it all out. If your data is changing constantly, like a live news feed or social media, RAG is what you need. But if your knowledge base is static or only changes once in a while, CAG is way simpler, way faster, and less of a headache to build. RAG can handle a basically unlimited amount of knowledge, whereas CAG is still limited by that context window, even if it is a gigantic one.
So, just think about the perfect use cases. Things like a fixed set of company FAQs, a bunch of legal contracts for review, historical archives, a detailed product manual. For any of these, CAGing is pretty much a no-brainer. The data doesn't change, so you can just load it up once and get lightning-fast, super accurate answers without all the extra machinery of a retrieval system.
Okay, let's zoom out for a minute. The rise of CAG isn't just about some new, cool technique. It's actually a sign of a much bigger shift in how we're all thinking about building things with AI. The focus is moving away from just crafting the perfect prompt to something much broader.
This quote from Anthropic just hits the nail on the head. The real challenge now isn't just about the words in your prompt, it's about being a curator. It's about deciding what precious information gets to enter the model's attention budget. Every model can only pay attention to so much at once, and our job is to make sure every single token counts.
And that right there is the big takeaway. We are all moving from being prompt engineers to becoming context engineers. Mastering a technique like CAG is really about mastering the art and the science of filling that context window with exactly the right information at exactly the right time to get the job done as well as it possibly can be. So I'll leave you with the final thought to chew on. We are on a path where context windows might as well become infinite, and the cost to fill them will get closer and closer to zero. So when that day comes, when we can give an AI the entire internet as context for every single query, what's the new bottleneck? What becomes the next great challenge in how we engineer knowledge for these systems? That's the question we're all going to be trying to answer next. Thanks for watching. Hey, welcome back. So in our last couple of explainers, we covered how LLMs get smarter with information using RAG and how they remember it with SAG. But that's all about thinking. Today, we're getting to the really exciting part, how these models actually do things. We're going to dive into how they connect to the rest of the digital world to take real action. So here's what's on deck. We'll kick things off with why AIs are kind of stuck in a box. Then we'll look at the classic tools that get them out, like APIs and webhooks. And then the really cool stuff, the new protocols like MCP and A2A that are basically teaching all AIs to speak the same language. We'll wrap up by looking at what this all means for the future. Let's get into it. All right, first up, the agent in a box problem. You've got these incredibly powerful AI agents, right? They can think, they can plan, they can strategize like nobody's business. But what good is all that brainpower if it's trapped? It's like having a master architect who can't actually pick up a hammer or talk to the construction crew. They're just stuck. And that is the fundamental question, isn't it? These agents can reason and plan, but how do they actually act? How do you connect that digital brain to, the real world of software and tools? How do we go from an AI thinking, book a flight, to a flight actually being booked? That's the gap we need to bridge. Okay, so the very first tool we have to solve this, the absolute bedrock of how software talks to other software, is the API, the Application Programming Interface. This isn't new flashy tech, it's been the workhorse of the internet for decades, and it's the first key to letting our AI agents out of that box. So what exactly is an API?
The best way to think about it is like a menu at a restaurant. You don't need to know how the kitchen works, right? You don't care about the chef's secret recipe or what brand of oven they're using. You just look at the menu, the API, and say, I'll have the weather for today. And a moment later, the waiter brings you the weather. It's that simple contract between you and the kitchen.
And this right here is the magic of what we call abstraction. It's all about hiding complexity. On the one hand, you have the mind-bogglingly complex inner workings of, say, a music app, all the code, the servers, the databases, and on the other hand, you just have a play button. The API is that brilliant, simple interface that lets our AI agent just push play without needing a PhD in software engineering.
Okay, so APIs are great, but there's a problem with the classic way of using them. Imagine your AI needs to wait for an email to arrive. Using a traditional API, it would have to ask the server every single second, is it here yet? How about now? Now? This is called polling, and it's super inefficient. It's like constantly refreshing a web page. There has to be a better way, right? Well, there is. It's called a webhook.
And this comparison just nails it. API polling is that annoying kid in the back of the car going, are we there yet? Are we there yet? Are we there yet? It's constant, repetitive asking. A webhook, on the other hand, is like saying, hey, just text me when we arrive. It flips the whole thing around. The agent just sits back and waits for the server to send a notification when something actually happens. So much smarter. Let's look at a real-world example to see this in action. Say you have a tool like Splunk monitoring your systems. Suddenly, a critical issue pops up. Instead of an AI agent having to constantly check Splunk for errors, Splunk itself, the moment it finds the problem, fires off a message, a webhook, to a specific URL. On the other end, a tool like GitHub catches that message and instantly, automatically creates a detailed ticket for the engineering team. No polling, no waiting. It's instant and super efficient.
So far, so good. Our agents can use APIs to talk to tools and webhooks to get updates. But this created a whole new headache. Every single tool has its own unique API, its own special way of talking. So connecting an agent to 10 different tools means building 10 different custom integrations. It's a digital Tower of Babel, and it just doesn't scale.
And that brings us to the next big idea, the Model Context Protocol, or MCP. And honestly, the best way to understand it is with this one phrase, the USB-C for AI. Just think back to that junk drawer full of old chargers, one for your Nokia, one for your BlackBerry, another for your camera. It was a mess, right? That's what the AI tool world looks like right now.
So just like USB-C finally gave us one plug to rule them all, MCP is trying to do the same thing for AI agents and tools. It creates a universal standard. An AI agent, the client, can connect to any tool server that speaks MCP and just ask, hey, what can you do? The server then replies with a standardized list of its tools, and the agent can use them right away. No more building custom connectors for every single tool.
Now this sounds amazing, right? One connection to access all the tools. But there's a catch. And this quote from Robin Ebers on YouTube sums it up perfectly. Quote, the more of them you install, the dumber your AI becomes. We have to be careful.
Yeah, think about it like this, the 100 tools on the floor analogy. If you ask someone to fix a bike and you just dump 100 random tools on the floor in front of them, what are they going to do? They'll spend most of their time just trying to figure out which wrench to pick up, not actually fixing the bike. It's the same for an AI. Too many options can be paralyzing. So the real skill here is what we call context engineering, giving the AI just the right, curated set of tools for the job.
Okay, so MCP is sorting out how a single agent talks to its tools. That's a huge step. But what's the next frontier? Well, it's getting agents to talk to other agents. This is where things get really interesting.
And that's where the agent-to-agent protocol, or A2A, comes in. This is a new open standard pushed by Google, and its goal is simple. Create a common language so that AI agents, even ones built by totally different companies on different platforms, can communicate and work together. So you could have a specialized travel agent AI talking to a calendar agent AI, which then talks to a payment agent AI, all seamlessly collaborating on a complex task for you.
Now, it's really important to get this straight. MCP and A2A are not competing against each other. They're a team. They're complementary. A2A is for agent-to-agent communication, while MCP is for agent-to-tool communication. Think of it this way. One agent might use A2A to ask another agent for help. That second agent then uses MCP to talk to its own tools to complete the request. They work together perfectly.
All right, let's pull back and look at the big picture here. We've talked about APIs, webhooks, MCP, and A2A. What does it all add up to? What kind of future does this interconnected ecosystem unlock?
Well, what it unlocks is pretty huge. First, you get universal interoperability. Any agent can talk to any tool or any other agent. This allows for true end-to-end workflow automation, where a whole team of specialized AIs can tackle long, complex jobs. We're talking about a massive evolution from simple chatbots to genuine AI collaborators. And for developers, this is amazing. They can stop building endless custom integrations and start focusing on the actual logic of the agent.
So really, this whole integration ecosystem is so much more than just a technical improvement. It's the critical infrastructure that will unlock the real power of AI automation. It creates a network where the value of each agent increases as more agents and tools join, which leaves us with a pretty profound question to think about. When every AI can discover, communicate, and collaborate with any other, what incredible complex problems are they finally going to solve for us?